Given f of x is equal to a to the x, our goal is to find f prime of x. In other words, we're investigating what the derivative is of an exponential function. So first let's use the limit definition of the derivative. So f prime of x is equal to the limit as h approaches 0 of a to the x plus h minus a to the x all over h. Using a little bit of algebra knowledge, we can rewrite that as being the limit as h approaches 0 of a to the x power times a to the h power minus a to the x power all over h. And then in the numerator, both of those terms have an a to the x, so I'm going to factor that out. So it'll be the limit as h approaches 0 of a to the h minus 1 over h times a to the x. Now what we can do is be able to pull out the a to the x because our limit is dependent upon h going to 0. So it's a to the x times limit as h approaches 0 of a to the h minus 1 over h. Now at this juncture, what we're going to do is try to figure out what the limit as h approaches 0 of a to the h minus 1 over h is. So, therefore, I'm going to set a equal to e to the natural log of a because knowing the relationship between functions and their inverses, these two would be equivalent. So I'm going to make a substitution here. So therefore I have a to the x times the limit as h approaches 0 the limit as h approaches 0 of e to the ln of a times and at this point in time, we're going to do substitution. So I'm going to let the natural log of a times h, which means, by a little bit of algebra, h will be equal to m divided by the natural log of a. Now what we're going to do here is a little bit of substitution. So first we're going to let m be equal to the natural log of a times h. And we can do this because we know that m will approach 0 as h approaches 0. And since we know that m is equal to the ln of a times h, h will be equal to m divided by ln of a. So let's make the substitution now. And anytime we divide by a fraction, it's the same thing as multiplying by its reciprocal. So we go ahead and reciprocate that. And what we get is a to the x times the limit as h approaches 0 of e to the m minus 1 over m times the natural log of a. Therefore, we can pull the natural log of a out front. So we have natural log of a times a to the x times the limit as h approaches 0 of e to the m minus 1 all over m. And as we said before, that limit approaches a value of 1. Therefore, the derivative of f of x equals a to the x is f prime of x is equal to ln of a times a to the x.